Hello dear students, I welcome you all to second edition of online class on set theory class 11 mathematics. So in the last class we were doing types of sets where we learnt about first null set, which is also called empty set or void set. Yes, next thing we learned is singleton set where there is only one element within the set, right? And after that we learned something called finite sets. So today we'll continue the very same topic, that is the types of sets, and the first topic for the day is equal sets. Okay, so as the name itself suggests, two sets are said to be equal if and only if they have exactly the same elements, right? So let's see what is the meaning of this. So I've taken this example out here. Okay, so from the exercise I've taken these many questions, so I'll take few as an example. For example, if I take number 1, a is given to be this much. Now this is given in set builder form. Now let's try to convert this into roster form. Now x is that element which satisfies this particular equation. For example, we have x plus 2 equals to 3, means the value of x has to be, this 2 goes over there, 3 minus 2 is 1. Okay, so that means a is a set containing element 1 because the value of x is only 1, isn't it? So that's why a is a singleton set. Now b is a set containing element x where x is a natural number which is less than 2. And what is the natural number which is less than 2? It is only 1. So that's why b is also a singleton set, and in this set we have element 1, and in this set also we have got element 1. So that's why we say a and b are equal because they have exactly the same elements, isn't it? So that's why a and b are equal in this case. Okay, now next is a is given to with this. Okay, so where x is a natural number. Now let's see what is the value of x here. Okay, so if you take this one over there, you will get 3x is less than 3. That means x is less than 1, isn't it? When you solve this, you'll see that x is less than 1. Now, is there any natural number which is less than 1? Because x is belonging to a natural number, right? So, is there any natural number which is less than 1? No, right? So, that's why can I call a to be a empty set? Because we don't have any element here, right? Because this gives me x is less than 1 and x is a natural number. So we don't have any natural number which is less than 1. So that's why this becomes your empty set. Okay. And if you solve this, again, this also gives me x is less than 1 and x is a whole number this time. Now, is there any whole number which is less than 1? Yes, we have got element 0 which is less than 1, isn't it? So that's why, say, a is empty set but b contains element 0, right? Where b becomes singleton set. So that's why a and b, they are not equal to each other. All right, so similarly you can check for the remaining thing. Yes, okay, so verify and check whether they are equal sets or not. All right, okay, now let's move on to the next topic. Now the next kind of set is called equivalent sets. So please remember there's a difference between equal sets and equivalent sets. So two finite sets a and b are called equivalent and they are written as this way. Okay, so a, this double arrow means equivalent. Okay, so a is equivalent to b if they have same number of elements. That means the cardinality of a and cardinality of b, if both are same, then the sets are said to be equivalent. Okay, so next kind of set is called subsets. Now sub means it's a small part of a set. A set X is said to be a subset of Y. Okay, if every element of X is also an element of Y. Now what's the meaning of this? We'll try to understand. So basically there's a bigger set Y, and from that Y you are taking a small part. Okay, and that smaller part also forms a set, and that set is known as your subset of Y. Okay, so symbolically we write this as this way. See, X is smaller, right? So Y is bigger. So we have to write in this way. So you can remember using your less than inequality. For example, 1 is less than or equal to 2. That's how we write, isn't it? So here also x is smaller, so we write x is a subset of y. Okay, and see, if x is son of y, then y is father of x, isn't it? So in the same way, if x is a subset of y, then y must be called something of x, and we call it y as superset of x. Okay, so you need to remember one more thing. Now here it's like less than or equal to, isn't it? Now if I remove this equal to sign, then it becomes x is a proper subset of y. Okay, so proper subset means let a be any set and b be a non-empty set, then a is called proper set of b if every element of a is also a member of b, but there exists at least one element in b, that is bigger set, which is not a member of a. So it might be difficult for you to understand. Let's try to understand this using example. Okay, so before we take some example, you need to remember this formula as well. Suppose there's a set A which contains m element. This means number of elements in A is m. Now from that particular set A, we can choose few element and form subsets. Yes, so total number of subset that can be formed for A will be 2 to the power m, where m stands for number of elements in that particular set. Okay, and the number of proper subsets of A will be given by 2 to the power m minus 1. So this is a very important formula that you need to remember. All right, now let's take this problem. Now let's observe the given sets carefully. So A is given to be this, B is given to be this, and C is given to be this. State whether the following statements are true or false. That means A is a subset of B. This means A is a subset of B. Kindly see whether every element of A is a part of B. No, right? Because 1 is not present in B. So that's why I can say that A cannot be called as subset of B. So that's why number 1 is false. Similarly, number 2 is also false, isn't it? A looks bigger than C, and obviously 1 and 3 is also not present in C. So that's why second one is also false. Now let's check whether B is a subset of A or not. That means every element of B is present in A or not. Now 2 is present in B. The element 2 of B is present in A. That's fine. The element 3 of B is present in A. That's also fine. The element 4 of B is present in A. So that's why every element of B is a part of A. So that's why this can be considered as true. Okay. B is a subset of C. Okay, B is a subset of C. That's what we need to check. That means every element of B is a part of C. Is this true? No, right? Because 3 is there in B, but it is not there in C. So that's why 4 is false. C is a part of A, or C is a subset of A. Is this true? Yes. Because we have got 3 elements, 2, 4, 5 in C, and all of these are present in your set A. Okay. Next is C is a subset of B. Now let's check. Obviously no, because the element 5 of C is not present in B. So that's why we cannot say, or we say that this is also false. B equals to C. That means B and C are equal sets. No, because 4 and 5. I'm sorry. Here we have got 3 and here we have got 5. So that's why they are not equal. Alright. Next is empty set is a subset of B. So you need to remember one thing is empty set can be considered as subset of any set. Alright, so that's why this becomes your true. A and B are equivalent. This means A and B are equivalent. Now, when do they become equivalent? If they have same number of elements. But they don't have same number of elements because A contains 5 elements, B contains 3 elements. So that's why this is also false. B is equivalent to C. Yes, it is true because B contains 3 elements and C also contains 3 elements. So that's why this is true. A and C obviously no, right? So this is also false. Hope the thing is clear to you. With this, let's move on to the next topic. So next topic is power set. Now what is the meaning of power set? Let's try to understand. The collection of all possible subsets of a finite set A is called the power set of A and is denoted by P of A. Now power set means it is a set. Okay. Now within this set, the elements will also be the sets. Okay. And what are those elements? Those elements will be the subsets of a given set. Alright, what's the meaning of this? Let's try to understand using this example. So question says, write the power set of A where A is given to be this much. Okay, so if A is given to be this much, then let us see what are the possible subsets of this. Okay, so the power set is given by this. As I said, the power set contains only the sets as in elements. Okay, so the first subset of this becomes empty set. As I said in the earlier slide, that empty set can be considered as subset of any set. Okay, so empty set, that is set with no element, is taken first. Okay, now I'm going to take singleton sets out of this. So that means I'm taking 1, I'm taking 0, I'm taking 2. All right, now singleton sets are also done. Set with no element, singleton set, set with single element. Now let's make or let's form sets with 2 elements. Okay, so I have chosen minus 1 and 0 and formed one set. Now let me choose minus 1 and 2. So that is also chosen. Now let me choose 0 and minus 1 cannot be chosen because they are already chosen, isn't it? So let me choose 0 and 2. So 0 and 2 are chosen. Now I cannot choose 2 and 0 because 2 and 0 gives me the same set, and similarly 2 and minus 1 cannot be chosen again because we have already written this. So we are done with sets with 2 elements. Right, now we can take this whole set as a subset of itself. Okay, so you can do that as well. So if I choose, then I'll get this. Now let's count how many subsets are there for this. See, according to the formula, total number of subsets will be, see how many elements are there, 1 2 3. So the total subsets will be 2 to the power m, that is 2 to the power 3. And how much is 2 to the power 3? It is 8. Now let's see if we have got 8 subsets or not. 1 2 3 4 5 6 7 8. Right, so we have got the 8 subsets, and if all the possible subsets are kept within a set, this set is called the power set of A. All right, so that's what we need to remember. Okay, now again here question says, write the number of proper subsets of A where A is given to be this much. Now if a set contains m elements, then the number of proper subsets will be how much? It will be 2 to the power m minus 1. Now what is the total number of elements here? You see that there are 5 elements. So that's why total number of proper subsets will be how much? It is 2 to the power. This is total number of subsets. All right, so total number of subset will be 2 to the power 5, which is 32. But total number of proper subsets will be 2 to the power 5 minus 1. All right, so please make the correction. It is 2 to the power 5 minus 1, which is 32 minus 1, which gives me 31. All right, so next type of set is called the universal set. Okay, so as the name itself suggests, universal means the biggest set possible. In set theory, all the sets defined in a particular context are considered as subsets of a fixed set. Okay, so basically this means you take any set. In set theory, if you take any set, that particular set is considered to be a part of a bigger set, and that bigger set is known as your universal set. Okay, and usually it is denoted by capital U, or else it is denoted by this letter, and this is called xi. Okay, so this letter is called xi. Okay, fine. So in order to understand this, let's take this example. Question says, given A equals to this much, B equals to this set, and C equals to this set, which of the following may be taken as universal set or sets for all the three sets A, B, C? So basically what we need to see here is all this A, B and C must be part of or subset of one particular set. Okay, and that particular set is called, or the biggest set possible from where A, B and C are taken is called the universal set. Okay, so if I choose this, we see that B contains 0, but this does not contain 0. So that's why this cannot be taken as the universal set. Okay, because B is not a subset of this set. Alright, now let's take this one. So we have A containing 135. So let's see 135 is there or not. Yes, 135 is there. 0, 2, 4, 6, 8. So 0 is there, 2 is there, 4 is there, 6 is there, but 8 is not there, right? So that's why this cannot be taken as the universal set. Obviously this is empty set, this does not contain any element, so that's why A, B and C cannot be subset of this. So obviously the last part will be my answer, but still we'll check it. Okay, so we have 135. Yes, 135 is there. 0, 2, 4, 6, 8. 0, 2, 4, 6 and 8 all are there. 2, 3, 4, 6. So 2, 3, 4 and 6. So A is also contained in this set, B is also contained in this, and C is also contained in this. So this fourth one acts like the universal set for these three given sets. I hope the thing is clear to you. Alright. Now it is given that your universal set is a set containing number till 12. So 1, 2, 3 till 12. And A is given, B is given. Both are given in which form? They are given in set builder form. So you have to write A and B in roster form. Okay, so here they have not said that A and B are subset of this or not, but since this is given to a universal set, so that's why A and B will be the subset of this. All right, so that means the values of x will be coming from this set only. All right, and this value of x will also come from this only. Now let's see what is happening in A. So in A we have element x. This means such that, all right, such that 2x plus 3 is less than or equals to 18. Now let us check what are the numbers from 1 to 12 which satisfy this inequality. So let's begin with 1. So if I put x equals to 1, then this becomes 2 into 1 plus 3 is 5. 5 is less than 18, isn't it? So that's why 1 comes in this set. All right, now we have another one, that is x equals to 2. All right, so when x is 2, then this becomes 2 into 2. 4 plus 3 is 7. Again this is satisfied, so 2 also comes. So 3 to the 6 plus 3 is 9. Again it comes. So 4 to the 8 plus 3 is 11. 11 also comes here. Now 5 to the 10 plus 3, 13 is also less than 18. So 5 also comes. 6 to the 12 plus 3 is 15. Again it comes. Yes. Okay, so we have next is 7 to the 14 plus 3 is 17. Again this also comes. Now next is 8, isn't it? So we have 8 to the 16 plus 3 is 19. So that means x equals to 8 doesn't come within this set. So that's why A will be a set containing 1 to 7. I hope the thing is clear to you. Now similarly, if you see the numbers which satisfies this equation, that is x must be less than or equals to 40, then you see that only these numbers will satisfy this. That means if I choose 7, then it becomes 7 is squared, which is 49, and 49 less than 40 is false. So that's why we take only these many numbers out here. All right, so you may pause the video and note it down. So the next topic for the day is intervals as a subset of R. Now what does this R stand for? this R stand for the set of real numbers, or we can call it real line as well. Okay, so if I take A and B to be two real numbers where A is less than B, then we have got four different kinds of intervals which can be considered as subset of R. Okay, so first subset is called a set X such that X is a real number and A is less than or equals to X is less than or equals to B. This set is called closed interval. Okay, and this is denoted in this way. Okay, so whenever you say this is nothing but the closed interval a comma b, or you can call it closed interval ab. Okay, now what's the meaning of this? Let's see. Now for this, a and x can be equal because there is an equal to sign, and this means x can be equals to b and it must be less than b. Alright, so if I have to represent this in a real line, then we represent in this manner. Okay, now this is my a. Now the value of x can be equals to a. Okay, and b is out here. Alright, and the value of x can be equals to b, and in between a and b, whatever number comes, that also can be my value for x. Okay, so this particular graph is the graph for closed interval ab. Remember, closed means the endpoints are also included. That is, the endpoints are a and b. Yes, so a and b are also included in this set. So next is called open interval, and open interval is written in this way. Okay, now in open interval, a and b is not included because we see that a is less than x. That means a cannot be equals to x, and this x is less than b. That means x cannot be equals to b. So if I have to represent this in graph, then this is represented in this way. So a and b are there, but the value of x cannot be a. That means x equals to a is not included in this set. So if it is not included, then we put this kind of circle. Okay, and if it is included, then we'll put a dark circle. All right, so here b is also not included, so to exclude this b, we will draw a circle like this, and within in between a and b, whatever points comes, that will be the value for x. So this is called open interval, and whenever you see this bracket, this means a and b are excluded from the set. Okay, so next is called open closed. So this is open and closed. That means a is not included but b is included. See, a is not included, equal to is not there, but x equals to b can happen. That is, b is also included, and this is represented in this way. B is included, a is excluded, and similarly we have next is closed open interval. Okay, so a is included, b is excluded. Okay, so this is represented in this way. So pause the video and note down the points. Okay, so on the basis of the intervals as subsets of R, let's see these problems. So question says, write the following sets as interval. Okay, so you see that there is no equal to sign. So that's why this is your open and this becomes your closed. So that's why this is open closed interval minus 3, 5. Okay, so here we see that we don't have equal to sign. So that's why this becomes your open interval. So both contains equal to sign, so that's why this becomes your closed interval. So this is also closed interval. I'm sorry, this is open because there is no equal to sign out here. Now here, if you see, we don't have lower bound here. See, this is called lower bound and this is called upper bound. Upper bound is given, but lower bound is not given. So if lower bound is not given, then you have to write this as minus infinity is less than x. Okay, equal to cannot happen because x cannot be equal to minus infinity. Okay, so remember that. So minus infinity is less than x. So this becomes your lower bound, and if this is your lower bound, as you don't have equal to out here, you will put open out here. All right, and since we have got equal to out here, so we'll put a closed interval. Similarly, here we don't have the lower bound, we have only the upper bound, isn't it? So that's why here also we'll write the lower bound as minus infinity, and this becomes your open interval minus infinity comma minus 3. Now here sign is given in reversed order, but we have sign less than or less than equal to, isn't it? So if I write this in other way, this becomes minus 2 is less than or equals to x. That means we don't have upper bound given. See, this becomes your minus 2 is less than or equals to x, but we don't have this upper limit, right? So since upper bound is not given, now if it is not given, then the upper bound has always to be taken as infinity, not minus infinity, okay? Because upper bound means this way, whenever we go, we get infinity, and lower bound means we go to the left side, and whenever we go to the left, we go to the minus infinity. So lower bound becomes minus infinity and upper bound becomes infinity. All right, so this set can be written as minus 2 is less than equals to x, and this x is less than infinity. So we have got equal to, so that's why this become closed, and here we have to write open. So these are the answers for these questions. Now let's write down these intervals in set builder form. So here we have to have, since this open, so we have to write minus 2 is less than x, and since there is a closed, so that's why x must be less than or equals to 0. All right, so this becomes your set builder form. Minus 2 doesn't contain equal to, so that's why this is open, and since there is equal to, that's why they has to be closed. Similarly, since there is open interval given to us, so that's why there is no equal to sign. Here both are closed, so that's why equal to sign has to be included. Here this is closed, so that's why minus 9 will be less than or equal to x, and x will be less than 4 because there is open. Okay, similarly this, if you compare with this one, okay, so this becomes 3 contains 3 doesn't contain closed, this contains open, right? So that's why here 3 will be less than x. All right, so this can be written as 3 is less than x, or in other word you can call it x is greater than 3. Okay, so whenever you see upper bound to be infinity, you need not mention the upper bound. Similarly, we have got lower bound to be minus infinity. Okay, so minus infinity is less than x. Okay, and we have got closed, so less than or equals to 5. So this can less than equals to minus 1, I'm sorry. So this can be written as in this way, or this in other words can be written this way, where instead of this 5 I have to write minus 1. Okay, so similarly we have got the same case, but here since this is open, we have to write only less than. All right, so this becomes answer for this one. All right, okay, so let's take one more sum. So this says two finite sets have m and k elements. If the number of subsets of the first set is 112 more than the number of subsets of the second, then find the values of m and k. So basically there are two sets containing m and k elements. So let A be the set containing m elements and B be the set containing k elements. All right, so what will be the number of subsets of A? It will be 2 to the power m, isn't it? And the number of subsets of B will be 2 to the power k. All right, now the difference of the number of subsets is given to be 112, isn't it? So that's why we have 2 to the power m minus 2 to the power k equals to 112. So from here we need to calculate the value of m and the value of k. Now if I take 2 to the power k common, then this can be written as this much. Okay, so if you multiply with 2 to the power k to this, you'll arrive at the very same thing. And if you factorize this, you will get this much. Now let's compare both sides. So if I compare, here we have got 2 to the power something, and here also we have got 2 to the power something. So that's why 2 to the power k will be equals to 2 to the power 4, and this whole quantity will be equals to 7. All right, so comparing both sides, 2 to the power k equals to 2 to the power 4 means k is equals to 4, isn't it? And this full thing becomes equals to 7. Now let's put the value of k. K is 4, isn't it? So if you take this 1 over there, this becomes 8, and this 8 can be written as 2 to the power 3. So from here, if you compare again, you'll get m minus 4 will be equals to 3, isn't it? So from here, the value of m turns out to be 7. Alright, so therefore m turns out to be 7 and k is 4 in this case. Pause the video and note it down. Thank you very much.